Hi everyone, it's Mrs. H. Today we're going to talk about section 10.1, which is rational exponents. We've talked a lot about exponents this year, and so hopefully this flows just nicely. You do want to refresh yourself on your exponent rules if you don't remember them. We're going to look at a few of them as we go, so let's take a look and get started. First, let's look at our little list here. We have a few different exponents that we should know. 5 squared, well, remember that means just 5 times 5. 5 to the negative 2, that really means 1 over 5 squared, which means my answer to that is 1/25. Anything to the 0th power is 1, but what the heck? Why is there a square root in here? Let's think about some of the things we know and try to figure out that square root. If I have the square root of 5, what could I do to help me figure that out? Well, I could think about the square root of 5 being squared. When I square it, I get 5 back. Okay, awesome. We know that. We know square root and squaring are inverse operations. Now, let's pause for a moment and kind of look at something different. What about some variable b raised to the 1/2 power? That's going to be our base to the 1/2 power. I don't know what that means. So let's try something. Let's try squaring it. What happens if I square it? Well, now I've got to follow my rules and I need to multiply my exponents. So I'm going to multiply 1/2 times 2 over 1. Oh, let's see, that means that I have b to the 2 over 2. That means I have b to the 1, or just b left over. When I squared and I had the 1/2 power, those two things undid each other. When I squared over here, and then I had the square root, those two things undid each other. So those two things must be the same. What we can conclude from that is that b to the 1/2 power must be equal to the square root of b. Let's look at some others. What about b to the 1/3 power? Okay, well, what happens if I try to keep doing what we did? What if I square it? Well, I'm going to multiply my exponents. So 1 over 3 times 2 over 1 is going to give me b to the 2/3. That didn't help at all. All right, so let's go back, start again. What if I cube it? If I cube it, then 1/3 times 3 over 1, that's just going to give me b back. Cubing and cube rooting are our two inverse operations here. So what must b to the 1/3 be? Well, it must just be the cube root of b. What about b to the 2/3? Well, I just gave you a hint a minute ago. What could I do to think about b to the 2/3? I could think about that instead as b to the 1/3 all being squared. We now know the 1/3 power of b is the cube root of b. And what am I doing to that? I'm squaring it. But does it matter if I do 1/3 times 2 or 2 times 1/3? No. I could have b squared all raised to the 1/3. That's going to give me the same answer. But what that means is that I could take the cube root of b squared. Out of these two, I would just do whichever one was easiest for me. So our definition here, any base raised to a fractional power, the denominator is the index of your root. The numerator is just a normal exponent. However, it does not matter what order you do that in. So you could have either of these statements. All right, let's take a look at just a couple quick examples and see what happens with some numbers here. Let's start with number 1 and take a look at 81 to the 3/4. Well, 81 to the 3/4, if I'm going to use my definition from up above, I could do the fourth root of 81 cubed. Ugh, no way do I want to have 81 times 81 times 81. So instead, I'm going to choose the other way. I'm going to do the fourth root of 81, and then I'm going to cube that answer. If you don't know the fourth root of 81, you can break it up. 9 and 9, which is 3 and 3, which is 3 and 3. Oh, good, because a fourth root, I'm looking for 4 of a kind. I have 4 of a kind. That, remember, is just inside your parentheses. I need to cube it to get 27 as my final answer. What about something like number 5? There's a whole lot going on number 5 here. I do not really want to deal with roots and fractional exponents all in the same problem. I also don't really want all roots. If I think about writing this as a root, I'm going to have the fourth root of this whole thing to the negative third power. Gross, inside that thing, there's another cube root. That's just way too much. No, thank you. I could do it. I don't want to. So instead, what I'm going to do is I'm going to rewrite everything with exponents. And then I'm just going to use my exponent rules. This is 1 over 16 to the 1/3, which means I have 16 to the negative 1/3 inside my parentheses, raised to the negative 3/4 outside. Our power to a power exponent rule says we just multiply. So I'm going to multiply 1/3 and 3/4. My 3's cancel, my negatives cancel. What do I get? I just get 16 to the 1/4 power. Okay, that's a lot easier to deal with. I can take the fourth root of 16. I know the fourth root of 16. If you don't, you can break it up. 16 is 4 times 4, which luckily gives me 4 2's. And so my answer here is just 2. A lot of your answers are going to work out nicely, not all of them. So let's take a look at number 6 over here. Number 6, again, I would much rather deal with exponent rules than trying to think about these things as roots. So I am going to rewrite this one. This is 3 to the negative 1 inside my square root, which means I have 3 to the negative 1/2, and then I have 9 to the 1/3, but exponent rules say that you have to have the same base. So not actually what I want. I'm going to erase this. I don't want 9. What is this? This is the cube root of 3 squared. So when I rewrite that, now I can write it as a power of 3. Okay, let's see. I have 2 exponents with the same base being multiplied. That means that I'm going to add their exponents. I cannot do this addition in my head, so off on the side, I'm going to write negative 1/2 plus 2/3. I need a common denominator, so I'm going to make them over 6. 2 times 3, 3 times 2. I get 3 to the 1/6. What is that? That is the 6th root of 3, and that is the most that we can do. I do not know what times itself 6 times is equal to 3. It is an irrational number, so I'm not going to do that out. All right, let's do just a couple more with some variables in here. Let's start with, why don't we do number 10? Number 10 here, I have everything under my cube root, which means I have my whole parentheses to the 1/3 power. Now that I have this to the 1/3 power, what I can do is I can fake distribute that 1/3. Remember, everything inside is getting raised to the 1/3. 5 times 1/3 is going to give me a to the 5/3. B, 3 times 1/3 just gives me b. That's good. I'm happy with that. C, I have to the 2/3. I am not going to be so mean to you that you need to get rid of your radicals like this. I'm actually okay with leaving the answer like this, also because it said give the answer in exponential form, you don't need to worry about the fact that there is technically a cube root in the denominator here. We're just dealing with our basic rules for now. All right, one more thing to talk about, and that is using this to solve some problems. So let's take a look at a couple where we have to solve. Let's start with number 15. Number 15, our normal rules for solving these still apply. You still want to get your x by itself, which means to start, I'm just going to divide both sides by 6. I get x to the 3 halves is equal to 8. And now I want to undo the 3 halves power. You could think about what it was. You could think about it as the square root of x cubed and then undo each of those things one at a time. Let's see what we would do. I would square it to get rid of the square root, and I would take the cube root to get rid of the x cubed, but I can just do that in one step now. Now that we know these to be exponents, I can just say, oh, what did I do? I squared and I took the cube root. Let's raise both sides of this equation to the 2/3 power. This undoes each other, right? That's what we already said. So now I just get x. Now I just have to figure out what 8 to the 2/3 is. I do personally like to think about these as radicals when I'm trying to figure them out. I think it makes a little bit more sense in my head. Let's see, I have the cube root of 8. Do I want to square it? No, because actually I know the cube root of 8. It's just 2 times 2 times 2. So I have 2 squared. That's going to tell me that x is equal to 4. I've told you before, you are allowed to do anything as long as you do it to both sides. This is one of those wacky things that we're allowed to do. One quick note. We took the cube root of both sides. I do not need to worry about plus or minus when I do the cube root. We are going to have to worry about plus or minus if we ever take the square root or the 4th root or anything like that. So let's look at an example like that. Let's look at number 16. First thing, again, just divide by 6. Get rid of that 6. I have x to the 2/3 is equal to 9. Now, I'm going to think, I'm not always going to write this down, but I'm going to think about what this is. This is the cube root of x squared. What do I want to do to get rid of those? Well, to get rid of the cube root, I'm going to cube it. To get rid of x squared, I'm going to take the square root. I am taking the square root, so I have to put plus or minus. Let's see, I cubed it and I took the square root. I cubed it and I took the square root. And so I can solve this now. X is equal to, let's figure this out. I'm going to put my plus and minus right away in my answer so that I don't forget that that denominator of 2 is really a square root. 9 to the 3 halves, that is going to be the square root of 9. Definitely do it in this order. I'm going to have 3 cubed. That means my answer here is going to be plus or minus 27. You can always check these, plug in 27, plug in negative 27. Your calculator will do fractional square roots. If you put in a fractional square root, whoops, don't want to watch Netflix there. You just have to be really careful that you put it in parentheses. So if I was doing this, I would do 9 raised to the parentheses. I'm checking, whoops, sorry, wrong thing. I'm checking 27. So I'm going to do 27 raised to the parentheses 2/3. So I'll do 2 divided by 3. Close my parentheses, hit enter. Good, I got 9. Sure, I can multiply by 6 and make sure I got 54. Excellent, it worked. So we checked our answer. I think you know if you plugged in negative 27, it would also work. Another quick note about your calculator though, if I typed in negative 27, just to be safe, it is a good idea to always put extra parentheses when in doubt. But when I plug in negative 27 to the 2/3, I again get positive 9, And so I do actually have both of those answers. All right, one more question, and that's number 18 here. Well, for now, I'm going to just call this my pink blob, and I'm going to get my pink blob alone. So let's see. First thing I'll do is I'll add 3 to both sides. I get 2 times my pink blob is equal to 8. Divide both sides by 2. I get the pink is equal to 4. Now I can think about solving this more. Excuse me. What was in that pink blob? Well, it was t minus 6 to the 2/5. Okay, I know how to solve that. I'm going to undo this by raising both sides to the 5/2. I am taking the square root in a roundabout way, so I do need to make sure I do plus or minus. Over on this side, those cancel out. I'm left with t minus 6. On the right-hand side, let's see. I have the square root of 4 all to the 5th power. That's going to be 2 to the 5th. That is 32. So my answer is plus or minus 32. I like thinking about these separately. I'm going to write 2 separate equations. I think it's easier. T minus 6 equals 32. T minus 6 equals negative 32. If I add 6 to both sides, I'm going to get that t is 38. Over here, if I add 6 to both sides, I'm going to get that t is negative 26. I think it's helpful to rewrite it so that you have both of those answers. All right, good luck with these problems. Of course, ask questions in class, and then we're going to use this as we move on through this chapter. Thanks, everyone.